Now here we have another problem. And what you will observe about this pair of equations, the coefficient for the x, they are different. The top one is 1, because x is 1x, and the second equation is 3. And for the y, coefficients are different. Now it's totally up to you how you want to approach this problem. So you can aim to get the same coefficient for the x, or you can aim to get the same coefficient for the y. I'm going to work this problem two separate ways, two different ways. So what I'll do, I'll first approach it by trying to get the same coefficient for the x, and then in the other way I'm going to look at it and see if we can get the same coefficient for the y. Okay, so let's do this problem trying to get the same coefficient for the x. Now of course you will notice that here the x is 1, and for this, the second equation, the coefficient is 3. So I need to make this 3. Alright, so I'm going to multiply the top equation by 3, equation 1 by 3, and then the other equation, it's already 3, the coefficient for the x, so I don't need to trouble it. So I just multiply by 1. Multiplying anything by 1 doesn't change the value, does it? Alright, so let's multiply equation 1 by 3. But bear in mind, very careful, when you're multiplying the equation by an equation by any value, in this case 3, you have to multiply each term in the equation by that value. So we are multiplying this equation by 3, so each term by 3. I will give a little space to get our new pair. So 3 times x, that's 3x. And 3 times 3y, that's 9y. And 3 times 16, that's 48. 48. The other equation, we're multiplying it by 1, so nothing changes. And we need to eliminate the x. Now let me ask you a question. Do we add or subtract? You guess correctly. We subtract. Alright? Subtract if coefficients have the same sign. Both of them positive 3. And if you look at it, if you add, what will you get if you add the x's? You get 6x. And which you don't want. Because the aim of the game here is to eliminate either the x or the y. And therefore, we subtract. And when you subtract, term above, take away term below. So 3x take away 3x, nothing is left. 0, right? 9y take away 2y, 7y. And 48 take away 13, that's 35. So we have 7y equal to 35. So 7 times a number equal to 35. What is that number? To get this, the value of y, we can divide both sides by 7 to ensure that we get rid of the 7 here. And if we divide both sides by 7, 7 into 7, that's 1, so 1y. And 35 divided by 7, that's 5. So y is equal to 5. So to get the x value, we substitute the value that we have for y, which is 5, into any one of the equation. Let me just stick to equation 1. Now equation 1 says x plus 3y is equal to 16. But remember, we know the value of y. What's the value of y? We just found it, 5. So 3y becomes 3 times 5. So x plus, what's 3 times 5? 15. And then you group the constants over here. So x equal to 16 minus 15. So x is equal to 1. So y equal to 5 and x is equal to 1. And you can always test your solutions. So if x is 1, then 1x, this is 1. And if y is 5, 3 times 5 give you 15. So 15 plus 1 give us a 16 over here. Let's test it in the other equation. We're saying x is 1, so 3 times x is 3 times 1, that's 3. And y is 5, so 2 times y, that's 2 times 5 give you 10. So 3 plus 10 is equal to 13. So we are confident x is 1, y is 5. Let's do it another way, where we actually eliminate the y first. Now, we want to try a different approach to solving this pair of equations here. Alright? And we can aim to get the same amount of y. Now here, the coefficient for the y is 3, here it's 2. A nice easy way to do it is just to alternate. So this number 2, put it up here. I'll put it closer. Since I plan to use the other side, let me put it closer. So, and then the coefficient up here is 3, so we just swap the coefficients and multiply. And you will see exactly why in a moment. In both cases, you foresee we're going to get 6y, right? So we're going to multiply equation 1 by 2, which means that we need to multiply each and every single term by 2. Alright, so 2 times x, I'll give a little space for the new pair of equations. So 2 times x, that's 2x. 2 times 3y, that's 6y. And 2 times 16, that's 32, right? And for the other equation, equation 2, we're multiplying each term by 3. So 3 times 3x, that's 9x. 3 times 2y, that's 6y. And 3 times 13, that's 39. So now we want to eliminate the y and do we add or subtract. You don't even have to think about it now. If you add, you'll get 12y and you'll get 11x. So adding will not make any sense in this case, right? So we subtract. Smart thing to do would be subtract. Staying true to what we have up here. So subtract the equations if coefficients have the same sign. So yes, they have the same sign, positive 6. So we subtract. And if you look at it, it makes sense because adding would give you 12y. So it wouldn't be a wise idea to add. So we're subtracting. So remember, term above minus term below. So 2x take away 9x. What's 2 take away 9? 7. So that's minus 7x. 2 take away 9 is minus 7. 6y take away 6y. And this is the reason why we call this method elimination method. Notice the y is eliminated now, so to speak. 6y take away 6y, that's 0, zilch, not. And 32 take away 39, that's minus 7. So now we need to solve for x. So we need to get rid of this negative 7 here. So we can divide both sides by whatever you want to get rid of. In this case, negative 7. So we divide both sides by negative 7. And here, negative 7 over negative 7, anything divided by itself is 1, so we have 1x. And again, anything over itself is 1, so the value of x is 1. And we substitute the value of x into any one of the equations. Let me just stick to equation. Let me use equation 2, just for the fun of it this time. Equation 2 says 3x plus 2y is equal to 13. Now we know the value of x is 1. So 3 times x is now 3 times 1, right? Plus 2y is equal to 13. So 3 plus 2y is equal to 13. So 2y, you group the constant, is 13 minus 3. So 2y is equal to 10. So 2 times a number is 10. What is that number? Yes, you divide both sides by 2. And if you divide both sides by 2, here you get 1y, 10 divided by 2. So 1y, or just y, is equal to 5. So same solution, regardless of the approach.